First, we need to talk about what a system of equations looks like. When we graph a system of equations, you have two lines on the same graph. The solution of the system is the x and y value that work in both equations. That is shown on the graph by where those two lines intersect. So on example A, the point 1, 2, 1 is the x value, 2 is the y value. That is the solution for this system. So if the lines cross in one place, there is one solution to the system. If the lines don't ever cross, that happens when the lines are parallel, there are no solutions. And what do you think is happening in C? They're the same line. The blue line is underneath the red line. They are the same line, so there are many solutions. Every single point on that line is a solution to the system. First thing we need to do after that is check points to see if those points are solutions to the system or not. So we have the point 6, negative 1. We need to know if the point 6, negative 1 is a solution to this system of two equations. So plug 6 into x, plug negative 1 into y, see if the equation works. So in example A, we are going to do 4 times 6 minus a negative 1, and we'll see if that ends up equaling 25. You can type this into your calculator if you want, or you can do some mental math. This is 24 minus a negative 1 means plus 1. 24 plus 1 is 25. This one works. We now have to check that point in the other equation. So negative 3 times 6 minus 2 times negative 1. And we have to see if that one equals negative 16. We get negative 16 equals negative 16. That works. So yes, the point 6, negative 1 is a solution. If it only works in one of the equations, then it's not a solution to the system because it has to work in both of them in order to be a solution, which actually can save you time. If you're checking this and it doesn't work in the first equation, don't waste your time plugging it into the second equation, because if it doesn't work in one of them, then it's no good. Let's try negative 2, negative 8. Negative 2 is your x value, negative 8 is your y value. So 2 times negative 2 minus a negative 8. Can you just look at that and see that that's probably not going to equal 52? Negative 4 plus 8, yeah, that's not going to equal 52. So nope. That means negative 2, negative 8 is not a solution. Strategic laziness. If you know it doesn't work for the first equation, don't waste your time on the second equation, because it has to work for both of them in order to be a solution. So if it doesn't work for the first one, we don't care whether or not it does for the second one. Okay, there are 3 ways to solve systems of equations. There's the graphing method, substitution, and elimination. We're going to start with the graphing method. In the past, before we had these fancy calculators, we would graph each equation super carefully using a straight edge, being as accurate as possible, and see where on the graph do the two lines meet. The good news is we now have the graphing calculators, so I'm going to try to teach you everything you need to know about using the graphing calculators to do that work for you. Now, what button do we push in the graphing calculator to graph things? Y equals. So push y equals, clear out everything that's in there. The thing about y equals is the equation has to look like y equals stuff. These two equations in number 1 are not y equals. So we are going to have to do a little bit of work on paper to get our equations ready to put in the graphing calculator. So if we have 2x minus 3y equals 1, what do we need to do to get y by itself? Subtract 2x. So negative 3y equals negative 2x plus 1. We then divide everything by negative 3 to get y equals positive 2/3 x minus 1/3. Aren't you glad we're using the calculator right now? Who would really want to graph 2/3 x minus 1/3 by hand? That just looks kind of gross. In your graphing calculator, to do fractions, use parentheses and your division button. So parentheses, 2 divided by 3, close your parentheses. That's the fraction 2/3. Do you remember where the X button is? Next to the alpha button. Minus 1/3. We need to get the other equation ready to also put into the same window. So I would subtract x on both sides and get y equals negative x plus 3. In the graphing calculator, you move down to y2 equals, so down one line. Do not use the subtraction key for negatives. There's a negative key down next to the enter button. So negative x plus 3. If you get an error, it's usually because you tried to use minus instead of the negative key. Now we graph it. Your calculator takes a lot longer to graph than mine does. This one like zips through it. The only thing this calculator does slowly is open up for the first time. Everything else, it just speeds through it. If you have the grids behind your graph, you can look at this and count and see that the solution, the place where those two meet, is the point 2, 1. Now, if you want to copy these two onto the graph, you absolutely can. You can go into the table, and I do want you to see what the table looks like. In the table, the black is the x values, the blue is the y values from the first equation, the red is the y values for the second equation. So if you want to pick out points for the second equation, you have to skip over that blue column. You do the left column and the right column. If you're looking for points from the first equation, you look at the black column and the blue column. So it just kind of saves space by putting the y's next to each other. A couple of other reminders. I put it here on the notes. If the graph looks funny, try pushing the zoom button and then number 6. That will realign it to a negative 10 to 10, negative 10 to 10. The other question I get is, what if I don't have those grid lines on my graph? How do I get the grid lines? And I want you all to learn this so that you're not constantly saying, Mrs. Gilmore, can you put the grid lines on my graph quick? Everyone look up here. Push second and the zoom button. Do you see how it says format above there? Second zoom takes you into the format settings for the graph. Notice on the third line, you've got the options grid off, grid dot, or grid line. If you have an older calculator, you pretty much just have grid off or grid dot. The newer calculators also have grid line. So you'd move your arrow down and over to grid line and push enter to turn that grid line on. You can also change the color of the grid lines and the color of your X and Y axes, but on my calculators, don't. If you have your own calculator, you can customize it whatever colors you want it to be. My calculator, let's just leave it at black and gray because, you know, they're boring. Take a moment on number 2, get your 2 equations ready to put in the graph, and then we'll go through that process one more time. You should end up with 2 equations. Y equals negative 3/2 x plus 2, and y equals x minus 4. If you need help with how to rearrange your equation to get y by itself, let me know. Some of you are great at it. Some of you struggle with it a little bit and might need a little bit of help. When you're putting the first one in, you can do parentheses, -3 divided by 2, close your parentheses. Don't forget times x plus 2. Your other equation, x minus 4, and graph them. Now these two equations look a whole lot nicer. If we wanted to graph these by hand, it would be pretty easy to graph them by hand. But when we see them on the graph, do you see where these two meet? Do they meet at a nice, perfect whole number integer? No, they do not. So we could estimate, we could say that that's like, oh, it looks like about 2.3 comma -1.7, maybe? The calculator can tell you exactly where they meet. Would you like to learn how to make the calculator tell you exactly where they meet? Okay, so you're going to want to pay attention to these steps, and I will try to write these steps down. The first step is to push second trace. And in parentheses, I'm going to put the word calc. Do you see how the word calc is above the trace button? We're getting into the calculate menu. So second trace gets us into this calculate menu. Which of these options do you think we want? Number 5, intersect. Okay, the calculator is now going to ask you a bunch of questions. You answer the calculator by pushing enter. So it's asking, where is your first curve? Now, the calculator is assuming that you have like 17 things on this graph. So they're basically asking, which 2 things do you want me to find the intersection of? So see the little blinky dot on your first line? Hit enter to tell it, yes, that's my first one. Which one is your second curve? See the blinky thing on your second line? Hit enter to tell the calculator, yes, that's my second one. That's the one I want you to look at. And then it's saying, do you want me to guess where they intersect? Yes, I do. Push enter. And then bam, it puts that dot right on the intersection. And at the bottom of the screen, it tells us that that intersection is at 2.4, -1.6. So it gives you the precise point where those two lines meet.
So we don't have to graph it all graph.
On number 3, if we rearrange the first equation, we get y equals 3/2 x minus 3. If we rearrange the second equation, we get y equals 3/2 x minus 3. These two things are basically the exact same equations. And honestly, look at them. If you took the top equation and multiplied everything by 2, you would have the bottom equation. They're the same equation. Because they're the same equation, they're going to be the same line, which means many solutions. So in this summary down here, you can say, if it's the same line, then you have many solutions. In number 4, to save you some time, notice the second one is already solved out y equals for you. The top one is just like what we had in number 3. So this one becomes y equals 3/2 x minus 3. What is exactly the same in both of these equations? The slope is 3/2. If the slope is the same, that means that they are parallel. They never meet. There's going to be no solutions. So in this summarize, you might want to write, if the two lines are parallel, which means they have the same slope but different y-intercepts, then there will be no solutions.